Okay, hi guys, welcome to Biology Online with Henny van Vuren. Hi guys, here we are again. Just thought I'd quickly tell you about the evolution of the brain and how our brains became bigger and bigger over time. I do apologize for the background noise. My neighbor is mowing the lawns and his kids are playing outside with the dog and so on and so on. But hey, the work must continue, so here we go. Alrighty, so evolution of the human brain. Um, so intelligence is not just a function of brain size. That's quite important. Otherwise, if you have a huge brain, then you're going to be the cleverest. But that's not how it is. It's actually your brain in comparison or relative to your body size. Okay, and you can see here that humans have a brain volume 3 times larger than would be expected for the average monkey or ape with our body size. Okay, so obviously we started to rely more on our intellect than what we did on our toughness and brawn. Another important factor is the organization of the brain. It is evident in the development of the areas. If you look at the areas of spoken language, the two areas of the brain, these two have become highly developed in humans in comparison to other animals. So the area of Broca, B, is close to the beginning of the alphabet, close to the beginning of the brain. Broca, the area of speech, that controls your facial muscles and your lips and your tongue and so forth, whereas Wernicke is all about the understanding of language, which is this one over here. Okay, so let's have a little bit closer look. So your frontal lobe, we call this your cerebrum or your cerebral cortex, and then your frontal lobe specifically. Your personality is very much contained in the frontal lobe, but very much to do with memory and so forth. And in humans, this has become significantly bigger than our ancestors. The area of Broca, which sits right over here, as I said, Broca has to do with basically producing the sounds that we can then use to interpret in Wernicke's area as language. So it controls the muscles, the lips, the jaw, the tongue, the soft palate, and the vocal cords during speech, as well as our facial muscles for facial expression. And then we hear those sounds, they go into Wernicke's area, and that is about concerned with the comprehension of the spoken word, how we actually hear them. Okay, then lastly, our midbrain, the one that sits here at the bottom, that is called the cerebellum. And the cerebellum in humans have taken over a lot of automation for us. When you're walking, you don't have to think about balancing all the time. You just do it automatically. You just plod along, la 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 la. You can have a conversation, look at your Instagram or Snapchat or whatever it is, and there you go. So a lot of our motor or movement functions have been taken over by our cerebellum. We don't have to actively think about that anymore. And that freed us up to do other tasks with our hugely imaginative big brain. And this big brain gave us things like now we could do culture and we could do art and we could sing and dance and do all kinds of weird things that apes don't do. So let's have a look at the changes in brain sizes. Okay, so if we start with Australopithecus afarensis, Australopithecus africanus, okay, you can see 440 and 450 milliliters. And that took them a million years to grow by 10. That's really not great. Now, Paranthropus robustus and Paranthropus bossii, remember, if you look at the timeline, these are the ones that did not become Homo, but decided to go the brawn way. I'm all about might, not about intelligence. And they went 500,000 years, it went up to 520 mils, and then it remained that way until Paranthropus bossii eventually died out. However, when we go to the Homos, the one that's really interesting to us is Homo habilis, because habilis has the habit of using tools. Okay, remember that habilis has the habit of using tools, and its brain size was 575. But from habilis to erectus, and remember erectus is the first one to leave Africa, we're talking about 1.8 million years ago to 500,000 years ago, so 1.3 million years, the brain size almost doubled, 575 to 1100. And we've talked about the reasons behind this. It's because now habilis are using tools. His hands are free to do other things. He can actually remember how to use the tools, not just to make it by accident and then use it, but remember this is a better way of doing things. Remembering how to get the prey, remembering how to hunt, remembering how to avoid predators, and then starting to communicate, and so forth. Okay, so a huge jump. And if you actually look at the two skulls of habilis and erectus, you can see that it looks relatively similar. However, the brain volume is double. Okay, so double the brain volume between those two. That's the main difference. And so when we look at the cerebral cortex, it's part responsible for memory, attention, language, and thought. Hominins increase their ability to live in social groups and utilize collective learning. They got more time to carry out abstract tasks such as painting and sculpting and so forth, and we'll look at that with cultural evolution. The cerebellum, we've talked about that already. It's you basically take your conscious, the ones that you have to think about, motor skills, and turn them into unconscious. I don't have to think about these motor skills using my cerebellum. When motor movements can become unconscious, then you have more focus on other activities. So you can walk and control and basically record a TikTok at the same time. Then Broca's area, Wernicke's area. So the primary function of Broca is speech production, facial neuron control. The neurons are your nerves that control your facial muscles, and language processing. Whereas Wernicke is all about the understanding of that language, semantic processing, language recognition, and language interpretation. Just a nice graph to show you if this is where Homo sapiens are, this is where we are 0 million years ago. You can see we have the biggest brain by far. Big brain, yay! And then over here is a rapid expansion. And look, it's 500,000 years ago from Erectus. Bang. And before that, there's an expansion over there, and that basically came to 1.5, which was, yeah, where is it? It is this one, because that's Paranthropus. So this is Homo habilis. And there's the big jump, where we took our time, but we learned how to memorize things and so forth, use our brain. We did not rely on brawn. Okay. This one is just to show you body volume versus your height. So brain volume versus height, sorry. You can see, remember Homo florensis is a outlier. That's the tiny one that was found in Indonesia. He's quite modern, but he's tiny, tiny. Australopithecines, they became taller, but their brain volume didn't really change. And then when they started walking upright, the erectines, you can see how it becomes bigger, and eventually when we reach Homo sapiens, it's a huge explosion. Okay, and that is it. So thank you very much for your attention, and I hope this helps. Have a great day. Bye.